Hi, I'm Ben with Filthy Motorsports and Crawlpedia.com, and in this video I'll be covering ride quality as it pertains to the suspension system of a vehicle. Now, I've found that this is a very difficult thing to try and explain, mainly because we're using a mechanical system, being the vehicle, the suspension components, the shocks, and the springs, to essentially create a feeling, a seat-of-the-pants feeling that tells us whether we like or dislike a vehicle that we're in. Now, that doesn't necessarily translate to firm versus soft. You can have a soft riding vehicle that moves too much and kind of churns your stomach and is unpleasant, and you can have a tight, controlled, high-performance sports car that is comfortable to be in. Well, add to that personal preference, and you'll realize how difficult our job becomes when we're designing suspension systems and tuning shocks. So, when you look at ride quality, you have to look at a lot of different factors. So in this video, we're going to be covering the suspension system as a whole, basically what the suspension system is supposed to do, what the major contributing factors are, what the limiting factors are to get a specific ride. We'll go over different types of suspension systems, so solid axles, independent front suspension, leaf springs, as well as other types of suspensions that we'll kind of put in throughout. So if you're watching this video because you've got a specific application in mind, I'd suggest that you watch the whole thing because I'll be putting a lot of information in each section that kind of covers and helps explain ride quality as an overarching theme. We'll go over common modifications. So we have changing your shocks, we've got lift kits, we've got all sorts of bolt-on kits and suspension changes, including mid-travel and long-travel kits and airbags. We'll go over different budgets. So with suspension, it's really easy to let the vehicle snowball, and before you know it, if you're trying to build a desert racing vehicle, you'll have more money in the suspension than the vehicle's actually worth. So we always have to look at not just the vehicle and the customer's expectations, but the budget and make sure that we're making sense out of it. There's a lot of times where spending more money is not necessarily going to give you better ride quality. And then, of course, we'll cover having realistic expectations. You can't come to us with a Chevy Duramax and want it to be soft and comfortable and plush on the street and then handle at 110 miles an hour off-road as a chase vehicle while maintaining stock suspension geometry. So we have to have realistic expectations. So we'll try and cover all of that as best that we can, and we'll start by covering suspension systems as a whole. All vehicles have a suspension system of one form or another, and despite the differences in styles and configurations and sizes, they all serve the same purpose, and that is simply to let the tires of a vehicle move independently from the cab and the chassis where the driver and the occupants sit. So the tires need to move in order to adapt to variations or changes in the road, and the goal of the suspension system is to try and isolate those movements as much as possible. So the better the suspension system can do that, and the more predictable and consistent it can absorb those forces, the better the ride quality and better the perceived feel is going to be for the occupants. Of course, different vehicles have different expectations from the terrain that they're driving over. A track car, for example, only needs to adapt to slight changes or angle changes in the pavement. A daily driver has speed bumps and potholes and maybe some curbs to drive over. A Jeep or a trail rig has boulders to articulate over. And then a desert racer has 1-foot whoops to absorb at 100 miles an hour through the desert. In all of those cases, the same things are happening. Meaning that if you have an object, let's take this 2x2 rock that I have. If you have a small tire, we'll take for example a 33-inch tire on a 20-inch wheel, you'll have a very small sidewall and you're generally running high pressures, so you're not going to have a lot of flexibility or give within that tire. A 33-inch tire hitting a rock this size is not going to be able to absorb much, and thus it's transferring that energy through to the wheel that's hard mounted to the suspension system. And therefore, the suspension system is going to be responsible for absorbing that hit. If we move up to a 40-inch tire or a 42-inch tire on a 17-inch wheel, running 5 psi out in the trail, well, it'll drive over a rock like this and fully engulf it without transferring almost any energy through to that wheel. So a vehicle with a tire like that will drive over a rock like this and not even know about it. And so that would lead you to believe that a larger tire with a lot of sidewall is the key to a good riding suspension system. And it is up until a certain point. A 40, 42, and even a 37-inch tire is enough sidewall, but it still maintains good rigidity and sidewall flex on the tire. As soon as you get too far past that, so we're talking 46, 54, and we'll take it to the extreme with a monster truck or a mud truck tire, you end up having a lot of sidewall. And of course, tires are made out of rubber and they have air on the inside. They're essentially large springs. And unfortunately, unlike a spring on a suspension system where we've got shock absorbers to dampen the movement, there's nothing to dampen the rebound effect of a tire. And that's the reason you can have a $200,000 professionally built monster truck land from a 30-foot jump and make it comfortable for the driver, but as soon as it lands, you'll notice that they immediately rebound back in the air before they settle again. And that's because there's nothing that can be done to dampen the rebounding effect of those tires. And that's also why you'll find a limitation on trophy trucks or other high-performance vehicles that when they land, you'll notice that their tires stay immediately on the ground, transferring power and thus, keeping them in the race. So when we approach a suspension system or a vehicle that we're trying to improve, the tires and wheel size are one of the first things that we ask for. And what we're hoping for is a nice combination. We want enough tire and sidewall to absorb the small stuff, but we don't want it to be too big that it becomes unstable. So as soon as that tire impacts the object and it'll flex and give a little bit, anything that's left over will be transferred through to the wheel and the suspension system. As soon as that force gets transferred through to the suspension system, it'll cause it to move. And while there are different styles of suspension systems that we'll go over in a bit, they're all given a set amount of suspension travel. You can, of course, increase that and modify it and change it, but we're given a set amount of suspension to absorb it. So the travel is simply the distance from the full extension position of the suspension system to the full compression position. So we're given a set amount of distance to absorb any amount of force that is applied to the vehicle, and how that is controlled, how that is dampened, is what ultimately affects the ride quality of the vehicle itself. The key component to every suspension system is the spring. Its job is to push up against the weight of that vehicle to support it at the desired ride height. Springs come in many different styles. This is a coil spring. We'll also go over leaf springs and torsion bars and airbags, but they all serve the same purpose, and that's simply to support the vehicle at the desired ride height, and then also push down on the tire to keep it in contact with the ground when the suspension unloads. So while the spring does that very well, it's still a spring, meaning that if I were to drop the spring on the ground, it's going to bounce multiple times before it finally settles and levels out. And that's what will happen to a vehicle that only has springs. The front end, if it hits a speed bump, will cause the nose to go up and then back down and then back up and then back down and then back up, and it'll eventually settle. It might be a half a second or a second down the road or 30 feet down the road. And that's not only unpleasant because you're moving way more than you should be, it's also not great from a performance standpoint because it'll take you a half a second or a second before the vehicle stabilizes and is ready for the next bump. So in order to control the movement of a spring, we use a shock absorber. And a shock absorber is essentially a cylinder that's filled with oil, and as it cycles, it moves oil through small openings and past a set of valving shims. And these are essentially spring steel shims that are set up and configured in a specific way to restrict the flow of that oil, similar to putting your thumb over the end of a garden hose. And so that creates resistance in the upward compression stroke as well as the extension rebound stroke. What's great about a high-end set of shocks like these Kings is that we can configure the arrangement of those shim stacks to act very differently under different conditions. So we can tune the shock to high force or low force or high velocity, low velocity, high movement or low movement in both the compression and the rebound direction. And because we've got so much control over that movement, we're able to dial in the performance of the vehicle. As such, you really want as much of the vehicle's movement being controlled by the shock as possible, and thus the spring should kind of be out of the equation. You want that spring to be as light as possible, strong enough, of course, to support the vehicle at the ride height that you want, but mainly just to make the vehicle neutral so the shock can do its job. Unfortunately, most automakers aren't going to put $1,000 worth of shocks on a vehicle. It's quite the opposite. They're going to choose their shock manufacturer by who's going to be able to make it the cheapest, and that's why when you get a brand new full-size truck, you're likely going to end up with a set of shocks similar in size to this that have a piston slightly larger than a quarter. And it doesn't take much common sense to realize a shock like this is not nearly enough to control the movement of an 8,000-pound truck. Or if it is tuned for it, it'll wear out in 5,000 or 10,000 miles and become irrelevant. Well, suspension engineers know that. They basically assume that the shocks are going to get worn out, and to compensate for that fact, they'll go with a much heavier spring. And so they'll do a heavier spring that's also a progressive spring rate. So instead of compressing the same amount under the same load, every inch or every other inch is going to be significantly heavier than the previous inch. And that's calculated such that under the typical use of the vehicle, whether it's a Super Duty or a 4Runner or even the front of an independent front suspension vehicle, they give you a progressive spring rate that's supposed to be firm enough so no matter what you throw at it, it's just enough spring to keep you from bottoming out. The problem with this, however, is it's going to end up giving you a very firm ride. A heavier spring is going to move less and thus feel firmer. Now, when I bought my Super Duty, that's exactly what they did. They put a very heavy progressive spring rate in it. And around town and on the highway and in stop-and-go traffic, it was fine. I mean, it was a truck. It's exactly what you'd expect from a truck. It's got a firm ride. It acts like a truck. No complaints there. The problem is once you start to get aggressive with it, or when you drive over, in my case, the example I use is a set of nasty railroad tracks that I drive over on a regular basis. When the truck hits that first rail, the nose goes up too high and then it comes down too high and it's trying to settle. Well, unfortunately, by the time or before it is given a chance to settle, it's already hitting that second rail. And so that it makes those forces even higher. And then as you get over it, the rear end goes over those rails and the leaf springs push back and you get this highly uncontrolled, I call it the bucking bronco feel, where the cab is thrown side to side and it just feels extremely unpleasant. So the first thing I did was install a set of high-end King shocks that were specifically tuned and dialed in for not just the spring rates, but the weight of the truck, the way that it's used, and what my expectations were. And they made a day and night difference over those railroad tracks. The shock valving was firm enough that it was able to control that movement. As soon as the tires got over that first rail, the truck was already stabilized and ready for that next rail. And so that's an example of a suspension system that's firm and has been changed from being uncomfortable and harsh to being controlled and comfortable. So we can still make a firm suspension system more comfortable with a set of well-tuned shocks. So if I wanted to make the suspension system softer, and that's a very common question that we have, especially with heavier vehicle and larger trucks, is people are expecting to be able to spend more money on a set of high-quality shocks and get a better ride. Unfortunately, that's not the case because the shock absorber can only control the movement of the spring. It can't make that spring any softer. And that's a big misconception that's out there, and I think that accounts for a lot of improper shock sales out there. And it's certainly not something that we would do. If you're trying to get a softer ride, we won't build a set of shocks until we know that the springs are corrected. So in my Super Duty, I went with a coilover conversion, then went with a softer spring rate that allows the suspension to move freer and easier and softer. With that, we're able to go with a softer valving on the shock. We still have a relatively firm top end, so when you get aggressive with it, the shock gets firmer to keep it from bottoming out. And that made a significant improvement to the ride quality and comfort. However, there is a limit. There's only so far you can take that based off of how much suspension travel the vehicle has. So this is a 6-inch shock absorber, which is about the same amount of travel as my truck has. You settle the ride height at about mid-shaft, leaving me about 3 inches of up travel to absorb the movement of an 8,000-pound truck, or about 1,800 pounds on that front corner. So, as you can imagine, 3 inches is not a lot of space to be able to absorb and decelerate a truck that's that heavy. So we can't go so soft on the valving that every time I hit a speed bump it slams and bottoms out. We have to have enough valving in there that it'll dampen whatever I plan to hit with it in that given space. I call that the 90-90 rule. That's kind of the goal that we shoot for with our valving, and that is I want to be using 90% of my suspension travel when the truck is moving 90%, or when I'm driving the truck 90% all out. Under the roughest roads, under the most throttle, under as aggressive as I plan to get with it, I want to make sure that this shock is able to handle that, and so we tune that accordingly. Of course, if you're running your truck down fire roads, the valving needs to be a lot firmer than if the truck is just a grocery getter and spends its time on the street. If we go too soft on the valving, let's say that we've got our 3 inches of up travel. If the valving is too soft, if you hit a 3-inch speed bump, it'll feel really comfortable for 2.9 inches, and then you're going to slam into the bottom of that shock and have that harsh, jarring bottom out. That would be an example of a suspension system that is soft, yet uncomfortable and unpleasant because you get that uncontrollable, harsh hit near the end. So whenever we're doing shock tuning, we have to work within the available amount of shock travel that we have, and then tune it such that we're using as much of it as possible when the vehicle is driven as hard as it typically is. So that is a theory that we work with. That's how a shock and a spring work together. And now we'll go over different types of suspension systems to explain how they work in combination in those configurations. The most common type of suspension system that we work with is the solid axle. And that's where you have one axle housing that connects the two tires together. This type of suspension is found under many vehicles, both under the front as well as in the rear. And the advantage to this type of setup is it's generally affordable to build, it's very strong and reliable. We'll have a lot of customers that go to junkyards that pick up Dana 60 or GM 14-bolt axles, and on a reasonable budget, you can build that to handle 800 horsepower and 42-inch tires. And because of that reliability and being budget-friendly, you'll see a lot of people with Duramax trucks or Toyota Tacomas converting to a solid axle in what's known as a solid axle swap. And it's also why a lot of trail rigs and rock crawlers and mud trucks use a solid axle. It's because it's relatively cheap, it's affordable, and it's very, very strong. The downfall to this type of suspension system, however, is that any movement that happens on one side of the vehicle is also affecting the other side of the vehicle. So if the left tire impacts an object, you'll notice that the right tire is also moving. So when one side moves, it's not just that side of the suspension system that has to handle that movement. The other side is impacted as well, although to a lesser degree. So if you imagine driving down a dried up creek bed where each tire is driving over numerous boulders at a high rate of speed, that creates a lot of movement that can become quite violent. And that makes it tricky for the suspension system. Luckily though, in most solid axle applications, we've got a 1-to-1 motion ratio. And that means that the spring as well as the shock are attached directly to the axle. If the axle moves up 1 inch, the spring compresses 1 inch and the shock compresses 1 inch. And that not only makes the calculations very easy for the springs and the shock valving, it also maximizes the effectiveness of the shock absorber. So in a solid axle application, you'll have the solid axle positioned by some form of linkage system. You can of course use leaf springs, which we'll go over in another section, but here you'll either have a pair of radius arms, you might have a 3-link, this is a triangulated 4-link, or you might have a 4-link with a panhard bar. We're not going to go over the different types individually, but what you need to know is that the geometry of this link system has a very important effect on the chassis and the way that that chassis moves under acceleration, deceleration, and general driving. Most OEM vehicles, you don't have to worry about that. The engineers at Ford, Chevy, Dodge, all those have done a very good job and they make sure that things are moving freely. However, if you've designed your own link system, there are things you got to be aware of. So we'll get customers that'll call us saying that their vehicle nosedives under deceleration or under hard braking. And they hope that we can just change the spring rates and the valving to prevent that. Now, we can go with 1,000-pound spring rates so those shocks barely move, and you can brake as hard as you want to, and you're going to get no nosedive. Well, yeah, that's a bit of an extreme example, but you see where I'm getting with that. It's in order to have the coils and the shocks fix one thing, you're negatively affecting another thing. And that's just a universal truth of suspension systems. It's a give and take game. Anything that you do in one direction, you're going to lose something in another direction. Same thing with squat. When you accelerate, you'll see that some vehicles will squat down in the rear, whereas some drag racing vehicles will actually lift up in the rear, pushing the tires down. That's not done by the springs or the shocks. That's all the suspension geometry. Another thing we run into quite often is body lean. And that has to do with the suspension geometry as well as the placement of the springs and the shocks. If the coilover mounts or the top of the springs are really low, below the engine and the cab and the chassis, you'll have a vehicle that's top heavy on its own, and that's why it's going to want to lean over. And then depending on the placement of the lower coilover mounts and how that's set up, it'll also have an effect. We go over that in a lot more detail in our coilover setup and calculation video. So if you've got a lot of body lean where the cab is moving side to side, again, we can go with really, really heavy springs to try and prevent that, but then you're negatively affecting your ride. The only proper way to fix body lean, other than changing the geometry, is to add a sway bar. And so sway bars are one of those things that if you need them, you need them. If you don't, you don't. If you end up with a little bit of body lean, you need a small one. If you've got a lot of body lean, you need a big one. It should be the very last thing you do as part of a suspension system. So you'll notice that each individual component is responsible for its own thing. The geometry handles the movement of the axle, the spring supports the weight of the vehicle, the shocks dampen the movement of that spring, and then a sway bar controls body lean. Each piece should only be used to handle its own responsibility. So once you've got the link system set up and you're happy with it and things are moving the way that they should be, we focus on choosing the proper spring rates. Now, an OEM vehicle, most OEM vehicles, will use a standalone coil spring, and that coil spring will be paired with a secondary shock. In some applications, like some Dodges, they might put that shock down through the middle, but that doesn't make it a coilover, because the coil spring is attached to the frame by a coil bucket, not to the actual shock itself. So standalone coil spring suspension systems are actually quite frustrating, and a lot of customers call us trying to tune them, and they don't always like what we have to say because the only way to tune them, unfortunately, is trial and error. And so that's where I'll get a lot of customers with 4Runners or FJ Cruisers wanting to fix the rear end squat that they're experiencing. So they'll have their 4Runner, let's say, they'll put a heavy rear bumper, swing out tire carrier, rooftop tent, they'll put a bunch of gear in the back, and then that rear end starts squatting down. Well, to compensate for that, you either need a taller and or heavier spring. Well, you put a heavier or stronger spring in there and it'll support that load. Well, then you take that load out and then the vehicle is sitting 2 inches too high. Well, unfortunately, there's no adjustability with the coil spring, and you don't always get what the literature tells you. And so that's the other problem, is if a customer will call us and say, hey, what kind of spring do I need? I've added this much weight. And there's no chart that I can kind of go through. Each company has their own marketing material. They each have their own specific spring rate, whether it's progressive or linear, which we'll go over in a little bit. Ultimately, you kind of have to decide whether you want the vehicle to sit at ride height when the vehicle is empty and then a bit too low once it's loaded, or whether you want it to sit at the ride height that you want when it's loaded and then just a bit too high when it's empty, or something in the middle. So it's a little bit too high when it's empty, or it's a little bit too low once it's loaded. In the end, you find a coil spring, you put it into the rear end of that vehicle, you let the vehicle settle down. If it's sitting a bit too high or a bit too low, you got to go with a different spring. If you find a spring that finally fits and settles the vehicle where you want it to, if you jump up and down on that rear bumper and it doesn't move, well, that spring is too stiff. And like I said in the previous section, a shock absorber, no matter what we do with it, cannot make your spring any softer. So you need to swap that spring out again for something that supports the vehicle at the ride height that you want, and when you jump up and down on that rear bumper, you want to get it moving. So I know that's frustrating, and I know that it might take a couple of orders, and most places don't offer returns on springs. It's the first step that you have to go through before we can get to properly tuning shocks. So you want a spring, again, that's soft enough that you can get that suspension moving, but strong enough and tall enough to support the vehicle at the ride height that you want. To make it a little bit more frustrating, as soon as you add 300 more pounds or you shift things around, well, that spring is no longer going to work. So hopefully one of the other springs that you've bought in your trial and error process will. A better option, or the option we prefer most, is a coilover setup. And on a coilover, you have the springs attached to the shock body itself. And that not only makes a nice, clean, compact package, it gives us a lot of adjustability. Because not only do we get to choose the spring rates that go on there, we can add or remove preload to them, and that's what the upper coilover nut does. We covered coilover setup and tuning in one of our Crawlpedia articles, and we'll be making a video soon on that. But basically, you can rotate this upper collar to add preload to the springs that'll lift the vehicle up. If the vehicle is sitting a bit too high, you remove preload and that'll bring it back down. So not only do you have ride height adjustability now, you'll notice we've actually got 2 springs on this coilover. And so that lets us have 2 different spring rates. We can have one spring rate for the main ride height of the vehicle, so let's say the first 2 inches of up travel, and then we can transition to the heavier bottom spring to help keep the vehicle from bottoming out. So we can basically double or triple the spring rate as per our choosing, and you can choose where that happens even by adjusting the stop nuts. And those are the 2 nuts that are threaded on the shock body. A lot of people have questions as to what those are for, but those stop nuts, depending on where you move those, will stop the slider, which is that typically plastic piece between the 2 springs, and that transitions all of the movement down to the lower spring. So there's a lot of adjustability that we can do within a coilover, and that's part of the reason that that's basically the main reason that you'll find them on all high-performance vehicles from Formula One to trophy trucks. It's you get to choose the spring rates, the spring heights, where they transition, as well as the ride height. The positioning and placement of the springs or the coilovers, like I said, have a big effect on body lean. The lower the springs are, the lower the upper shock mounts are, the more weight you have above them, and that makes the vehicle top heavy. Again, more likely to need a sway bar. With coil springs, there is a limit to how tall they can be. If you've got a spring that's too tall, as soon as it compresses, it'll bend. And we'll see that a lot on Super Duties, for example, that have 8 inches of lift with large coils, because not only does the axle twist as it comes up, and that twists the bottom plate, most springs don't have a lot of linear rigidity to them. As I try and compress a spring, you'll realize it's trying to move in different directions. So there's a physical limit to the size of a coil spring for it to work well. If you've got an OEM vehicle or a Jeep or something and you're keeping it relatively low and you're on a budget, I'm a big fan of coil springs. If you get the springs right, we can tune a set of shocks very, very well to get you the ride that you need. If, however, you're building a more high-performance vehicle or a mud truck or a hill and hole racer or an Ultra 4 car, the rule of thumb is go with the largest coilover you can fit. Go with the 14, go with the 16, within reason. Get the upper shock mounts as high up as possible. The more travel you have, the more we can do with the tuning, and that just gives us a lot more flexibility. Ultimately, the way that the shocks are tuned and set up is going to determine, one, by how much travel you have, and again, the more travel you have, the lower the valving can be, so you get a softer ride. And then, depending on where your ride height is going to be, we'll have to do things differently. So on a rock crawler, for example, where you want to have a low center of gravity, we'll typically see about a 4 to 5 inch ride height. And with 4 to 5 inches of up travel, we'd have to go pretty heavy with the valving, especially if you're driving very, very aggressively. So what we do is, in order to go with slightly softer valving to make things move more, we'll use the stop nuts to transition between the softer spring combination to the heavier spring, and we'll always try and pair them with a set of hydraulic bump stops. So with a 4 to 5 inch ride height and a 3 inch hydraulic bump stop, you'll have an inch of movement on the softer spring combination, then you'll transition to the heavier spring, and then you'll have a super progressive bump stop that'll control the rest of that movement. So while it's a small amount of movement, we can dial that in and tune that in very specific ways, so you actually have a very comfortable, well-performing vehicle that not only works well on the trails, but you can also blast down the desert with it. So if you're able to do all of those things, we can get you a very good ride. If, however, you don't have hydraulic bump stops and you want to have a 3 inch ride height or a 2 inch ride height that we've seen on a couple occasions, well, there's not much we can do. We can either go very heavy on the valving to try and keep you from bottoming out, or we can go softer on the valving and you just have to live with bottoming out quite often. That's the trade-off. For hill and hold racers and mud trucks, we'll typically try and be about mid-shaft. Normally, you've got at least 12 inches of travel. Oftentimes, we'll see 14, 16, and even 18. We'll go about mid-travel, and then you've got plenty of movement in each direction. And when you've got that much movement, you're going to have a soft riding vehicle that's performing very well because we've got so much distance to absorb that in. One common issue, one place where we run into that fine balance is with lifted full-size trucks, so Dodges, Fords, Chevys that have been solid axle swapped. If you're trying to keep a relatively low ride height or a stock height, like I said previously in this video, you might only have 3 inches of up travel. Well, if you've only got 3 inches of up travel, the valving has to be very, very firm to absorb that 2,000 pounds per corner within that amount of space. So if you've got the ability to lift the truck to go up a little bit higher, I say that the sweet spot's right around that 10 or 12 inch coilover. Get that around mid shaft, and if you've got 6 inches of movement in each direction, well, that's a big difference, and we can go softer on the valving, get you a nice street ride, let that suspension move a bit more when you drive over bumps, still have it handle well on the highway, and you've got a very comfortable and high performance full-size truck. So it's not just the positioning or the placement or the type of the spring, it's finding that fine balance of what works best for your application and then trying to find a sweet spot within the shock travel and your ride height. At least with the coilover, you can play with that ride height. You can bring it down to 3 inches, you can bring it up to 4 or 5 inches, see where it works best, and then fine tune it. And worst case scenario, you just have to swap out a few springs to get you where you need to be. So I'm a big fan of solid axle applications. They're very easy to tune and dial in if they're set up properly. We have a lot of options for springs when we go with the coilover setup. And even if you've got a standalone spring, I know it's a little bit more frustrating, but once you get that spring figured out, the shock valving, again, based off of the ride height and the amount of available travel, is very simple to set up. So that's the way that tuning and ride height and positioning works with a solid axle application. And now we'll move on to an independent front suspension that isolates the two tires from each other. In an independent suspension system, as the name implies, the tires are allowed to move independently from each other. So the advantage to this, as you would expect, is that if you properly tune the suspension system, you can have a tire impact an object, isolate those forces, absorb those forces, and keep them from being transferred through to the cab and the chassis or the other tire, like happens in a solid axle application. Because of that, if you have an independent suspension system that's properly tuned, that is always going to give you the best ride quality for any given vehicle. And that's also why automakers and manufacturers are moving towards having independent suspension both up front as well as in the rear on their newer vehicles. So by its design, it's going to be a lot more complicated than a solid axle. We have a lower control arm. We have an upper control arm. We now need a CV shaft that has pivots both at the differential and at the knuckle to allow that power to be transferred through those angle changes. And we also need to have pivots on the steering system so that those linkages can move with the tire. So it's quite a complex setup, and I think for this reason it's one of the most misunderstood. It has a lot of advantages, but then it also has a lot of drawbacks that we'll get to. And one of those that can actually be both a benefit and a drawback is the fact that the spring and the shock are mounted to the lower control arm and they're leveraged, usually pretty close to a 2-to-1 ratio. So that means if you've got 10 inches of travel on the tire, the shock and the spring are going to be moving 5 inches. Well, that also means that they're seeing twice as much weight and twice as much load. If you've got a gas Toyota Tacoma with a V6 engine in it, by the time that weight is leveraged, the spring and the shock are actually seeing about the same amount of weight as they would under a diesel Ford Super Duty. Well, the way we can use that to our advantage in high performance applications is by getting more travel out of the tire. So in a trophy truck where we can get 28 inches of tire travel, we only need to use a 12 or a 14 inch coilover, and while it is working twice as hard, you pair that with a bypass shock or you run a larger cylinder to absorb those forces, and that way you've got a nice, reliable, very effective suspension system that has a lot of travel. So there's a lot of things we can do with an independent front suspension system or a rear suspension system, but we have to keep in mind the geometry is really important, the angles at which everything moves has a significant effect, and there's a lot of limitations as to what we can work with it. But even though we've got those doubled forces, they're still within the range of what we can handle with a shock absorber. So while the factory shocks are going to be these small generic shocks again, we can still use a King 2.5 shock to handle those forces. Because again, we'd use this on a Ford Super Duty. So if we put them on a Tacoma or a 4Runner, they're able to absorb those forces, no problem. And the better part too to that is, while we have to go much firmer on the valving to absorb the energy within a small space on a Super Duty, while that's a 1-to-1 motion ratio, here we're leveraged, so the firmer valving on the shock ends up being softer at the tire. When it comes to the spring, again, there's no real problem there. It's a mechanical spring. We can go really high up on those spring rates, and then what happens is just the coils get a little bit thicker. Only thing we have to watch for here is that when you've got a short, high rate spring, there's a risk of the spring coil binding. So if that compresses too much and all the coils start to touch each other, that turns into a solid steel spacer, and that can cause some problems. So we have to walk that balance, but there's plenty of springs available for coilovers in these applications. While we're on the subject of springs, their responsibility is still the same as they are in a solid axle application. Their job is simply to support the vehicle at the ride height that you want, and then be neutral so that they allow the vehicle to move and flex. We get a lot of phone calls from customers that want us to use a very specific spring rate. There's a lot of misinformation on internet forums out there where they'll call us wanting to build a set of King shocks with a very specific spring rate because they read it somewhere on an internet forum. Well, remember what I said before. If you go with a higher grade shock that can do more work, you don't want to have a heavy spring. You want that spring to be as light as possible to make the vehicle neutral so that the shock can handle those forces. When we choose springs for an independent suspension system, we of course take into account the weight of the vehicle, the leverage effect, where the ride height's supposed to be, whether the vehicle has an aftermarket bumper and winch or rooftop tent or anything else that's added to it. And we basically run the numbers and increase the spring rate or reduce the spring rate to set that ride height, and then, again, try and keep it as light as possible. There are desert racing applications where you're running 100 miles an hour through the desert where you do want to increase the rate of that bottom spring to keep the tires on the ground, but that's pretty rare and that's only for racing setups. So with the springs, if you're contacting us about your Tacoma or your 4Runner or your F-150, let us choose those spring rates for you. There's plenty of energy that can be absorbed with that shock. We want the springs to be neutral. So with that said, one of the biggest problems we run into with independent front suspension vehicles is people having unrealistic expectations from them. They're really happy with the ride quality that they have out of that truck, and so they lift it by cranking adding preload to the coilover or adding a spacer to that coil spring, and they're basically pushing those arms downward, thus lifting the vehicle. Well, we're only given a certain amount of travel to work with. The tire's only going to move a set amount, and that's typically around 7 to 9 inches at the tire. Well, the sweet spot is going to be right around mid-shaft. You're going to have 4 or 5 inches of up travel, 4 or 5 inches of down travel, and that'll adapt to just about anything that you're driving over. You can lift it up a little bit more and you have 4 inches of down travel and 6 inches of up travel. You're still going to have very good ride quality out of it. Well, as soon as you lift it too much, all of a sudden you don't have much down travel left anymore. So if you've only got an inch or two of down travel and you hit a 3-inch pothole, that suspension overextends, and as soon as it overextends, it's got a hard hit, and then it's going to pull the vehicle down into that pothole because it's got nowhere else to move. And so that creates a really unpleasant ride. Not to mention, when you lift it that far, all of your geometry ends up being at steep angles. So your CV shafts are going to wear out sooner, your steering linkages, your ball joints, your tie rod ends, everything starts to wear out sooner when you lift it up too high. So I'm going to say it multiple times throughout this section because we run into it time and time again. The sweet spot for most trucks, pretty much all of the ones that we work with our OEM kits, is going to be about 2 to 2.5 inches over stock height measured at the tire. Anything more than that is going to cause the vehicle to ride like a freight train. It's going to be very, very harsh. And there's nothing we can do about it. You can't put everything out of alignment, out of geometry, and have no down travel. There's nothing we can do with the shock valving or the spring rates to make that ride well again. So those are the orders that we just say, hey, we'd rather just not take those. We can't do that. If you want to have 3 inches of lift and good ride quality, you need to get yourself a lift kit that drops the lower control arms down, gets you a longer knuckle, drops the differential down, brings everything back into the proper geometry at the amount of lift that you need. Well, all of those components are going to cost the same whether you want a 3-inch lift or a 6-inch lift. And that's why you don't see a lot of that. If you're going to spend the amount of money it takes to lift a truck 3 inches properly, you're generally just going to go straight to 4 or 6 inches and go all the way. So once we know where the ride height is going to be on that truck, then we can focus on the spring rates and the valving. And all of that is going to be pretty much exactly the same as I said with the solid axle setup. We choose valving based off of the amount of up travel that you have. We choose it whether you've got hydraulic bump stops. We choose it. Usually you don't have a dual rate setup in an independent front suspension vehicle. Now that I'm talking about springs, it's usually just one coil because you only have room for one coil. So unlike a solid axle application where you can transition between the two, you're only going to have one coil. And you're going to want that coil with a good shock to be a linear rate coil spring. There's a lot of companies pushing progressive rate springs, digressive rate springs, all sorts of different things. Those are used for lower quality shocks. When you go with a high performance shock, you want a relatively light, consistent linear spring rate. So we choose the proper spring rates, and then the valving can be used to handle whatever you're doing with it. As long as you have the suspension system set with a good amount of up travel and down travel, we can tune it to be very nice on the street. We can tune it for desert racing. We can tune it for expedition use when you've got the whole vehicle loaded and set up. And you've got, you basically have the best of both worlds. Once you get to modifying the suspension system, and that's where we start talking about mid-travel and long travel kits where you've got longer lower control arms and longer upper control arms, well, that's where things start to get tricky, or they get better because we've got a lot of options. If you're going to go to the point with your build that you want a new lower control arm and a new upper control arm, my biggest recommendation, and I'll go over that later on in the advice section in this video, go all the way. Either stick with the stock suspension geometry, work with it, it's the best bang for your buck, or go all the way. Lower control arm, upper control arm, full coilover conversion, leave room for a bypass shock, put a hydraulic bump stop in there. If you start piecemealing your way to try and get there, you'll get frustrated. So either work with the stock suspension geometry as is, possibly replace the upper control arm. That'll generally allow you to get a little bit more down travel, and it'll slightly adjust the camber. We'll give you a recommendation as to whether we think that makes sense for your application when you call. But either stick with the stock suspension geometry or go all out and replace everything. So that's about all I'm going to go over on independent front suspension systems. This is going to apply for your I-beams. It'll apply for twin traction beams from Ford. Anything that has the tires independent from each other, so if one tire moves and the other one doesn't, all of this kind of applies to that. So hopefully that gives you a good idea on independent front suspension systems. And now I'm going to move on to leaf springs. Leaf-sprung suspension systems are most commonly found in the back of pickup trucks, as well as some SUVs, and then some older trucks and SUVs also use leaf springs up front. The great thing about leaf springs is they're extremely simple, they're reliable, they're bulletproof, and they position the axle as well as act like the spring. So we don't need any linkages or A-arms or anything. The leaf springs themselves will position the axle. By their design, they're made up of multiple lengths of steel. Usually there's 2 or 3 leaves in there, and they have a very progressive heavy spring rate. And again, that's by design. Because they're used on the back of pickup trucks, those springs need to work well whether that truck is empty or whether that truck is loaded. Generally, they'll be a little bit too firm for an empty truck. As soon as you put 200 or 300 pounds in the bed, they'll nicely soften up and be in that sweet spot of their spring rate. And then if you add 400, 500, 600 pounds to it, they'll get into the really heavy springs or the overload springs, and they significantly firm up. So that progressive spring rate, while that is their benefit and that is their advantage to be able to adapt to load changes quite well, it does also allow them to be very good on the compression stroke with shocks. There's very little we have to do on the compression stroke for leaf springs. The problem, though, is as soon as that energy is compressed into that spring, it releases itself almost violently. And when it does that, as the vehicle is sitting on that axle, as those springs unload, it actually pushes up on the back of that truck bed and it transfers that energy to the front. And so a lot of times when a customer will spend a lot of time, money, effort dialing in and tuning the front suspension on their truck, I'll still get calls about them complaining about a rough ride, a firm ride, something that just still doesn't feel right, and they can't figure out why the suspension system up front can't handle it. And the reason is that feeling that you're getting from the front is actually coming from the rear. assuming we don't have leaf springs up front, as that suspension system drives over a bump and absorbs it, it's done with it. The rear end drives over that bump, compresses, unloads, shifts that energy back to the front, and so you're feeling every hit twice. First when the front axle hits it, and then once after the rear axle comes off of it. And that's where you get that harsh feeling because of the rear leaf springs, despite the front being done correctly. Well, there's a few things we can do in the back of a vehicle that has leaf springs. And if the truck is still used for towing and hauling large amounts, if you're a pipeline welder, if you haul a 15,000-pound trailer that's a gooseneck, well, you kind of still need those leaf springs. You can't haul a large load without having heavy springs for it. And if that's the case, well, you have to have realistic expectations. You can't have a truck haul 15,000 pounds and then also ride like a Cadillac. You're going to have heavy springs. And what we'll do is we'll build shocks that have really heavy rebound valving in it. So when you do hit those bumps, it prevents it from unloading too far. The idea is that it unloads back to ride height and stays there. So we can dramatically improve the ride quality of a vehicle like that under those conditions. Well, if you don't tow or haul that often and the truck is normally empty or with mild weight in the back, the first thing you're going to need to do is replace those leaf springs. Instead of those heavy 2 or 3 leaf factory leaf springs, we want to go with a 7 or 8 or 10 or 12 leaf pack, and we tend to work with Deaver spring on those. We've had great results with them. We recommend them highly. I run them on the back of my truck, and I can't say enough about them. You get a very it's still a progressive leaf spring, but it's much less so than the factory spring, so it's almost like having a linear spring rate, which is what we want from a performance suspension system. Once you replace those leaf springs with higher quality, softer leaf springs, you get much less of that unloading factor, and we can put lower rebound valving into those springs. And by improving the ride quality of the rear of the truck, you've now improved the ride quality of the entire truck. So while going to a softer leaf spring will usually result in a reduction in towing and hauling capacity, you can make up for it. And what I suggest is a set of airbag overload springs, usually in the form of an airbag like this, that mounts to the frame at the top and then it mounts to the axle on the bottom. Usually it's just out of the equation, you run just on the leaf spring, and then when you add a load to the back of the truck, you add pressure to the airbag, it expands, pushes down on the axle, and then you level the vehicle back out to ride height. Now, an airbag works pretty much exactly the same as a leaf spring. It's a super progressive spring rate. So when you add a super progressive airbag to a super progressive leaf spring, well, you got to kind of forget about ride quality for a little bit because you're going to have a really hard unloading effect on it. So that's why I recommend this for applications where you don't tow or haul too often. With my truck, it's no longer my tow rig anymore. It's my parts runner. I just run around town with it, but every once in a while I do have to move something heavy. So I'll use the airbag for it. I'll inflate it, brings back up to ride height. Yeah, it'll be a little bit bouncy, but it'll let me get the job done, and then I let the air out of it. I've gone one step further with my truck. Instead of having it hard mounted to the frame as well as to the axle, I use a Daystar lower airbag cradle. And this allows the airbag to settle into that cradle when I need it. And then when I'm done with it, I let the pressure out of the airbag, I put a cap on the Schrader valve, and it stays compressed up and out of the way until I need it next. So I recommend that quite often, actually pretty much every day, multiple times, the Deaver leaf spring and airbag combination, because it solves both the problems. You significantly increase the ride quality of the truck while also maintaining towing capacity when you need it. Because the airbags work very similar to the leaf springs, everything that I've kind of said here also applies to an airbag suspension system all the way around. The only difference is you can adjust the spring rate of the airbag. And so while a leaf spring is fixed, you can change the pressure in the airbag to make the truck move softer. It doesn't even have to be a truck. It can be a Cadillac. It could be anything that's on airbags. You can play with that spring rate to soften it up. But under a hard hit, you're still going to have heavy unloading, and you'll need heavier rebound valving in a shock to adapt to that. So that is something that we recommend all the time to trucks. It's basically day in and day out. You focus on the front first, you get this front suspension working really well, and then you soften up those rear leaf springs. And it also applies to vehicles that use leaf springs front and rear. We run into a lot of customers that, for the simplicity and the bulletproof nature of leaf springs, will run them front and rear. And if you run a long leaf spring that's relatively light, you can get pretty close to a linear spring rate. There are other things you can do. You can extend the length of that spring by putting it under the axle. And we do that with a lot of desert racers as well. So instead of the spring coming up and over the axle, we'll bring it down and under with an extended shackle. And by going longer, again, the spring rate can be reduced. There's less preload in it, so we need less rebound valving. While I'm on that subject, whenever you make this type of change on, let's say, a Tacoma, usually we run into it with a Tacoma or an F-150 or a Tundra, a lot of the OEM manufacturers build their shock mounts really close together, and so most of the OEM kits that we offer that are a direct bolt-in will only work with the factory leaf springs, or maybe allow it to drop down an extra inch or two. As soon as you go with a softer spring rate, a lot of the Devers will allow you to get 2-3 inches or more down travel, more suspension travel out of it, which is always a good thing. We're limited by that shock. So with Tacomas in particular, if you're going to go with the Dever leaf spring, we unfortunately can't build a shock that fits the stock mounting locations. So you need to look into a rear shock relocation kit that moves the mounts up so you can finally fit that larger shock in there, or you'll temporarily have to run on a set of Bilsteins or Ranchos. If that seems a bit too much and it's too involved to move all the shocks, the biggest improvement is going to be on those leaf springs. I would way rather change the leaf springs with a set of softer leaf springs and run a Bilstein shock than to run the factory leaf springs with a well-tuned set of Kings. So that's that fine balance that we go through a lot. It's not always the best or perfect ideal. We got to work with what you have. Another thing that we run into, and unfortunately there's nothing you can do about it, is a situation where you get that hopping effect when you're driving down a road with the expansion joints in it. Again, we get this all the time. Unfortunately, it's the power of oscillation. If the expansion joints on the road that you're driving over perfectly line up with your wheelbase and the speed that you're driving at, no matter how good the suspension system is, those forces start to build, and that's where you get that bucking bronco effect. You can change the speed, slow it down, or speed it up and try and skip that oscillation. But a well-tuned suspension system is going to let you go a little bit longer before it gets uncomfortable. A firmer, less controlled suspension system is going to get unstable right away. But that is a question we get quite a lot, is trying to improve the ride quality over those expansion joints. And unless you change the wheelbase of the vehicle or change your speed, there's really nothing you can do about it in the long run. My truck is about the nicest riding Super Duty you can ever be in. Unfortunately, there's a stretch of highway on my way home that has its separators perfectly lined up, that about 3 or 4 seconds into that highway, it's already moving uncontrollable. So that's something that unfortunately is just the nature of the suspension dynamics, and there's not much we can do about that. So overall, I think leaf springs are one of my favorites. I really love tuning them because they are super reliable and they're very simple and you can do a lot with them. That covers that, and now what we'll do is we'll go over lift kits, suspension kits, and I'm going to give you a lot of points of advice that I tell customers on a regular basis. So now that we've gone over suspension theory and the different types of suspension systems quite a bit, I wanted to leave you with some basic advice that I pretty much give every customer. There's stuff that is good to know regardless of the type of vehicle that you're working with, and to help set you on the proper path. And the first and foremost, kind of the most important thing that I want you to know, other than having realistic expectations, is to realize that no vehicle is going to be perfect for everything. You can't really build a vehicle that is nice, soft, and smooth on the street, articulates and flexes really well off-road. You can bash through mud pits, run 100 miles an hour through the desert, and then tow 1,000 pounds in a truck bed. It's just, I'm sorry, you're not going to be able to build a vehicle that does all of it, or at least that does all of it very well. Now, certain types of those applications, street and trail running, yeah, we can build something that works perfect for all of those. Street driving and towing, absolutely. Street driving and desert racing, absolutely. There's a lot of combinations that there's things we can do with the valving and the setup to do all of them, but you've got to be realistic. You have to kind of choose what's most important to you, focus on that, and remember that all vehicles are going to be able to do everything. You can have your F450 dually and take it out on the trails. Yeah, no, it's not going to flex very well. No, it's not going to ride very well, but it's not stopping you from doing a trail run if it comes up. So keep in mind that no matter what we do, the vehicle's still going to be able to do everything, and it's generally going to be able to do it pretty well. But when we're dialing in ride quality or trying to get the best ride quality and performance out of a vehicle, we want to focus on what you do the most. If it's going to spend 95% of his time on the street and then you occasionally go trail running with it, let's focus on that. yeah, you'll be able to run 70 miles an hour through the desert. It might not be the most stable at those speeds, and you might not be able to drive, there very long, but you'll be able to do that and chase your buddies for a little while. If things shift and you end up doing a lot more desert racing, then let's go in and revalve it. Let's put a heavier top end into it so it handles those higher speeds a lot better. So there's things we can do to tweak it, but you want to focus on what's the most important, and we want that, the way that the vehicle is used most of the time, that's where we want the ride quality and the handling and the performance to be best. Another thing to keep in mind is when it comes to valving and tuning, it's not always ride quality, it's ride consistency and predictability. And that's something that I think a lot of people miss. You're not trying to tune a suspension system that you can throw down any logging road and have it handle perfectly. That's not what the goal is. The goal is to be able to build a vehicle that can bomb down a logging road and be consistent and predictable. You know how big of a tree stump you can hit. You know how big of a dip you can go through. It's that continuous knowing what's going to happen. In a poorly tuned suspension system, it might have all the travel in the world and it might have trailing arms and A-arms and everything. Well, if the suspension system is not tuned properly, it might be comfortable on the street, it'll become highly unpredictable and you have no idea what to expect with it. So don't always focus on ride quality or ride performance. Focus on predictability and consistency. That's just as important. The other thing is when you're focusing on your suspension system, it's not about spending the most amount of money. The example that I always think of was a Raptor owner that contacted me because he had spent $4,000 to $6,000 on a brand new set of shocks all the way around, and he was sold, I think they were either 3.0 or 3.5 bypass shocks. I'm not going to name the brand, but they were shipped to him. All the bypass tubes were closed. He put them on the truck, and it rode like a brick. Well, as you'd expect, bypass shocks need to be opened up. And then the other thing is, his truck's used as a daily driver. He spends most of his time on the street and on the highway. He's never blasting off-road at 100 miles an hour, which is what those shocks were designed for. And unfortunately, some dealer out there managed to sell him on this way overpriced set of suspension. Well, maybe it's not overpriced. The quality was definitely there. It's just not what he needed. And the problem is, luckily I was able to go in and have him open up the bypass tubes and, soften up that ride, and we made it work for him. And so that was a customer I was able to help without charging a penny. But he shouldn't have spent that money in the first place. And that's a big part of what we focus on is knowing what the vehicle is, knowing what your expectations are, and getting you what you need, not necessarily selling you the most. There are cases where you do have to spend a little bit more to get the performance that you need, but there's always a limit to it to find a good balance. Along those lines, you have to focus, or you got to be cautious for one-size-fits-all bolt-on kits. So that includes a lot of specialty lift kits and coilover conversion kits and long travel kits. A lot of them are sold to be easy. You basically take them out of the box, bolt them up, and then you go for it. Well, the reason you got to be careful with those is they're designed for the middle of the road user. They choose spring rates and shocks and a combination that works for the generic person. Now, if you are the generic person, you're probably going to be pretty happy with it. If you've got your built truck and you use it the way that kit was designed for, you're great. However, if you've added bumpers and winches and roof racks and spare tires and all that kind of stuff, well, chances are the suspension is going to be too soft for you. And we get that phone call a lot where someone has bought a one-size-fits-all kit, and then it's sagging or it's sloppy and it's not working, and that's because your vehicle is heavier than they designed it for. Same thing if you've removed a lot of weight, the suspension is going to be too firm. And so while a lot of those kits are great and they do a good job, you have to go into it either expecting to make the tuning, adjusting the valving yourself or changing the spring rates yourself, or what I suggest is contact us, let us know what your plan is, we'll point you in the right direction, find a good lift kit or suspension kit or coilover conversion kit. There's a lot of great ones out there, and we've got relationships with a lot of great companies that can help you out there. But when it comes to the spring rates on the shocks or the coilovers, and whether you need hydraulic bump stops or not, leave that up to us. Let us ask all of the questions that we need to know, how things are set up, how things are placed, whether or not you're carrying a full-size spare tire. Let us ask all of those questions, and then we'll come up with a set of shocks and springs that you'll be able to take out of the box, bolt onto the truck or on the vehicle, and you'll have the performance and the ride handling that you need. And better yet, if it's not where you need it to be and you need to make some tweaks, we offer a free spring exchange. If you cover the shipping cost, we'll swap you out on the springs. If you need to tweak the valving a little bit, we'll help you with that. Well, our job's not done until the vehicle is riding and performing and handling the way that it's supposed to be. And that's part of what being a suspension dealer is all about. Your job is not to sell a customer a product. It's to make sure that the vehicle handles, performs, and rides the way that it's supposed to. So we offer a service where if a customer contacts us with a suspension system or the race vehicle and it's not working the way that it's supposed to be, for $100, you get 1 hour of our time and we'll review the spring rates and the valving and everything to see if we can make that work. And a lot of times we can, or a lot of times we'll say, move the upper mounts in a little bit, the lower mounts out, change this angle, change that angle, and for $100, you've got the suspension dialed in the way that you need to, and it's a lot better than spending $2,500 on a new set of shocks or whatever. We work with customers in Australia and Japan and Thailand and Europe and Russia and pretty much South Africa. We've got customers all around the world where they'll contact us looking for a new suspension system, and we'll talk them out of a $3,000 suspension system plus all the shipping and taxes and duties and stuff to ship them where they need to, and we'll fix what they need for $100, and they just source some springs or they'll order some valving. So we do that day in and day out, and we're happy to do that. But we have to draw the line somewhere, unfortunately, and with as popular as our YouTube channel has become, and we've got a lot of repeat business and a lot of word-of-mouth business that we really appreciate, and we thank you so much for all of that, we're already at about a permanent 2-week backlog, or 2-day backlog, sorry. Hopefully we don't get to that point, but we're about 2 days behind on all of our messages, and that's become almost a permanent thing. We call back on all of our messages. If you call and leave a message, I promise you, we'll call you back. With emails, we're about a day behind, especially during the busy season, but we will get back to you. And being that busy, we kind of have to pick and choose who we're able to help. And I had to draw the line somewhere, and I draw the line at fixing other dealers' problems. Especially with these YouTube videos, we've been getting a lot of customers that have gone elsewhere, bought a set of suspension systems, and guess what? It's too firm, it's too soft, it's not doing this, it's not doing that. And I'm sorry, it's not my job to fix the other dealers' problems. That's what their responsibility is. Contact them, tell them that it's their responsibility to help you fix it, and make them fix it. If they have to watch my YouTube videos, make them do that. I'm willing to help. But we've got too many new customers to help, and racers and stuff to help with tuning and adjustments that we just can't deal with, fix other dealers' problems. So I do apologize about that. I know that it's a bit harsh, but we've had to draw the line somewhere. Maybe if you're really nice and polite and kind, I can never turn someone down if they're really nice. And if you make it easy for us, we'll help you out. We'll make it right. It's a $100 fee. We'll do that. But just getting tired of, as you can tell, fixing other dealers' issues. Along those lines, it's set up a good plan. Figure out what you're trying to do and set a budget. I've seen way too many times where a project has snowballed and a customer has bought shocks 3 or 4 times, replacing something as you go. We run into that a lot with Tacomas and Jeeps, for example. I'll use the Tacomas as an example where you think you can use it as a daily driver, and so you replace the front coilovers and you put some shocks in the rear. Well, the next step from there is replacing the rear leaf springs, and as I covered in the previous section, the King shocks don't work with those leaf springs. Well, you either need to do a rear shock relocation kit and buy new shocks and do all of that, or just get rid of the Kings and run some Bilsteins. Well, that wasn't ideal. You just spent a lot of money on those Kings. Up front, if you go with an aftermarket upper control arm, you got to spend that money on the control arm, and then you got to go into the shock and remove the shaft spacer to get the down travel. So each time you're improving the ride of the suspension system, you've got to get rid of existing parts and then go in and fix some of the existing parts to make it work. And then once you've gone that far, you realize, well, maybe I should have gone with a mid-travel kit, and then you're going to get rid of everything up front with control arms. And before you know it, you'll end up with the suspension system that you're ultimately going to want, but you'll have spent, 2 times as much to get there. And that's why we try and focus on, from the beginning, what is your end goal? What are you trying to get out of it? What's reasonable? What's not? What are you willing to spend? And we would rather you hold off spending the money up front, do something to hold you over, save up, and then do it all at once. You'll get there faster, you'll get there cheaper, and you'll get there with a lot fewer headaches. So we have that conversation with a lot of customers. I was going to go into that more into this video, but I think you get the idea. Set a plan, set a mark, think it through, and just do it once and get it right. Don't overthink it. We all get into those dreaming stages where you come up with an idea and you dream of the end goal, and we create your spreadsheets and you figure out where you want to be. You'll realize really quickly that you'll end up with a trophy truck, or you'll end up with an Ultra 4 car. If you're going to go that far and you've got $100,000, $200,000 to spend, you'll always go with the tube chassis. You don't want to build your vehicle into that. I've gone through that personally with my F-150. I was going to try and keep it streetable. Built it, got it to the point where I was doing a 4-link conversion and everything on it, and I realized that I was going to gut all the stuff that made it street legal, and once I was finished with it, I spent more time, more money, more effort, and I ended up with something that's not really ideal. Works great, but had I started from the beginning, I would have done things completely differently. So I've done it myself, and yeah, I'm letting you know from my experience. And then, of course, you got to make sure you've got a fine balance. You don't want to spend too much money or put too much under the front end of a vehicle and then neglect the rear, or vice versa. You want to find, when you're spending your money, that you spend it in the right way to get a nice, balanced, overall, well-performing vehicle. So I think I've already gone past the hour of which I tried to keep this video under. As you can tell, I can talk about this for hours and hours. So I do apologize. Hopefully I've been able to keep your attention, at least teach you something about ride quality and suspension. As always, I really appreciate you watching. If you've got any questions, make sure to leave a comment under this video. I get to them as often as I can. I personally respond to all of them, and I help out as much as I can. Give us a call. 720-545-2279 is the number. Leave a message. I'll get back to you with when I get a chance. Email is sales@filthymotorsports.com. If you've liked the video or any part of it, please make sure to give us a +1. We really appreciate that. Make sure to subscribe. We've got a lot of other videos coming. They take a while, as you can tell, but we put a lot of effort into them. So give us that like. We really appreciate that. In the end, we've got a lot of this information on our websites. Check out filthymotorsports.com as well as Coilopedia. Again, I'm Ben with Filthy Motorsports, and as always, thanks for watching.